This is the continuation of the previous video. So let's start with user-defined function part 2. Let's start with function as an object. In Python, pretty much everything is an object, whether it is a number, function, or even modules. Before explaining why function as an object, let me tell you one thing. Suppose consider this is a memory, that is a primary memory. And within Python, suppose you have written a equal to 10. That's mean in case of Python 10, the value 10 will occupy some space within primary memory. Whichever occupies space in memory, it is called object in programming language. In reality, which occupies space is referred to as an object, but in case of programming language, the variable or the value which occupies space within primary memory are referred to as object. In traditional programming language, variable occupies space in memory, but in case of Python, the value occupies space in memory. And from now on, we will refer to this 10 as an object. This is an integer object because 10 is an integer. Again, we have to assign some name for this object. We assign the name of this 10 as a. That means a is pointing to the value 10 or the integer object 10. So when we are writing b equal to a, that's mean b is assigned with the same address as a. That's mean I mean to say that the value 10 is residing within the memory area. That's mean it has some address, it has some starting or an ending address. This a holds the starting address of this memory, or in other words, we can say that a is pointing to a. And when we are writing b equal to a, that's mean the address of a will be copied into b. That's mean b is pointing to the same memory location, that is 10. So whenever we print a or b, it will print 10. But if I write c equal to 20, the 20 is a different value, so it will occupy a different space within memory, and c will points to that memory. So in the same way, list, tuple, dictionary, whatever the data type we used in Python programming language are all considered as an object. Similar to this data type, function is also treated as an object. Let me show you how. Suppose I have written this code in Python. It's a function. Here I have written def. This is the name of the function multiply. It accepts two arguments, x and y, and it evaluates x multiply y, and the value is returned to the segment of the code from where the multiply has been called. Now from the main code, we are calling the multiply function along with the two values, that is 2 and 3. So 2 will be initialized within x, 3 will be initialized within y. These 2 and 3 will be multiplied over here, and that will be returned to the main code. And since multiply 2, 3 has been written within a print statement, so 6 will be printed in place of this function calling area. Now look what happened within the memory. Similar to integer, list, string, etc., this return x multiply y will occupy a space within memory, and this memory will be referred by multiply. That is the name of the function. Since this multiply is referring to an memory space, that is why this is also called an object. Now in the program, suppose I have written like this: product equal to multiply. Product equal to multiply means this multiply object has been initialized within this product. That's mean the address where the multiply is referring is copied into the variable product. So the consequence is like this: the product variable is now pointing to this memory location. We can say that product is the alias name of multiply. Both product and multiply are pointing to the same memory location, so these are treated as object. Now look at the last line of the program, print product 5, 6. Just like multiply, we can call the multiply function with the product object along with these two arguments 5 and 6, so it will behave same as multiply. You can think as that the product is another name of multiply. Both are referring to the same memory area, or it is referring to the same code or the same function. That's why multiply 2, 3 and product 5, 6 will behave in a similar way. That's why I have written function as an object. That means we can treat this function as an object. With the help of this concept, I will show you the method of passing function as a function parameter. Before explaining this topic, let me show you one thing. Suppose we have a two function. This is define function 1 and it accepts a parameter f and it has some body. And look at the second function, def function 2, it has also some code to execute. Now from the main code, suppose we are calling the function 1, but this time the parameter of the function is another function, that is function 2. Previously we have seen that during function calling we can send integer, float, string, list, tuple, dictionary, etc. Just like them, we can also send a function in the parameter listing of another function. So here the function 2 will be copied into f. That's mean internally it is doing f equal to function 2. The address of function 2 will be copied within f. That's mean f and function 2 are pointing to the same block of code. Or you can say that f is another name of function 2. So executing f is similar to executing function 2. Let me show you an example with respect to this explanation. First of all, let me define a function. Say the name of the function is add. It accepts two arguments x and y and it returns x plus y, that is the summation of x and y. Now let me declare another function, say do twice. The function arguments are func, x, y. Now within this do twice function, let me return func within bracket, say I'm again writing func within bracket x comma y, and there will be another parameter, again func within bracket x comma y. Now come out from this function, let me write the main code. Within the main code, let me initialize two variable as a equal to 5 and b equal to say 10. Now let me print and then call the function do twice, and since do twice function accepts three parameters, so let me send the add function, the value a and the value of b. Now look what happens over here. This add function will be copied within this function variable, or you can say the function object. Now a will be initialized within x and b will be initialized within y. Again I am repeating, when we are calling this do twice function, it is sending three parameters, that is the add a and b. Add is a function and ab are the two integers. So here in that do twice function, func will hold the add, x will hold the value of a and y will hold the value of b. You can think that func and add points to the same block of code, that is it is pointing to the add function. Since a is 5, so x is also 5. Since b is 10, y is also 10. Now look how the operation is going on. So this is a function, that's mean you can say that this is an add function. So within this add function, there is a function x and y, that's mean there is another call of add function with 5 and 10. Again there is a function call, func call, you can say that this is an add xy means 5 comma 10. The last bracket is the closing of this add function. So within this add function there are two calls of the add function. So this add function will execute first, that's mean it will send 5 and 10 to the add function, and this add function will make a sum of 5 and 10, that is 15 will be returned over here. Similarly, when this function is called, again 15 will be returned over here. Now after completing the innermost operation, then the outer add function will now execute. So the outer add function will send two parameter 15 and 15 to the add function. So this add function will now return 15 plus 15, that is 30. This 30 will be returned from here. Since do twice has been called from the main code, so this will be replaced by 30. Again I am repeating, when this do twice function is called with this three parameter, add will be initialized within func, the value of a, that is 5, will be initialized within x, and the value of b, that is 10, will be initialized within y. Here the function FUNC has been called along with these two parameters, where the two parameters are itself the function FUNC. You can think that this function is nothing but the add function. So within its parameter, again the two function has been called whose names are FUNC x, y. That's mean it is calling the same add function. That's mean you can say add 5, 10, add 5, 10. When this add function is called with these two values 5 and 10, it will return the sum of 5 and 10, that is 15. Again, when this add function is called with 5 and 10, so again it will return 15 over here. Now look at the outermost add function. This time it got its two parameter in an integer format, that is 15 and 15. So these two 15 will be sent to add function. It will make a sum, that is 15 plus 15, 30. It will be written back over here. That means this will be replaced by 30, and this 30 will be returned to the main function. That means this will be replaced by 30. Let me run the program. Look at the result at the left hand side. Look, it is 30. Now come to the next topic, variable number of arguments. That's mean when we don't know how many parameters are to be sent during the function call. So in that scenario, we use variable number of arguments. Let me show you the technique. First of all, let me create a function, say myFUNC, and in the argument let me write asterisk argv. You can write any variable name. It is up to your choice. Since it is accepting some argument vector, so I have written argv. Now within this function, let me print the argv. Let me see what it is receiving. Now come to the main code. Within the main code, let me call the my function, and suppose the parameter is say hello, welcome, then to, then Python. That's all. That's mean we are sending 4 string. We can also send 1 string, we can also send 10 string. When the number of parameters are not known to us, in that case, what we have to do? We have to write a variable name along with an asterisk sign. So this will hold all the parameter within a tuple. Now when we print argv, we can see the data type where these parameters are residing. So let me run the program first. This argv is nothing but a tuple. This tuple is capable of holding any number of parameters. Suppose I have added another string, say suppose programming. Now if I run the program, this time the tuple will be look like this: hello, welcome to Python and programming. Now within the function, you can also print this argument in different lines. For that I have to use for data in argv. Let me print this data in a separate line. Look at the output. So it's print the tuple and then it prints the element of the tuple in a separate line: hello, welcome to Python programming. So when the number of parameters is unpredictable, in that case we have to use this technique. Let me show you another variation. Suppose within the function I have written say arg1, this is argument 1, and after that I have written star argv. Let me print the first argument is like this. First argument, the first parameter will be stored within the first argument, and the rest of the argument, that is from welcome to Python programming, will be stored within star argv. So when we print first argument comma arg1, look what happens, and within this argv we will extract the rest of the parameters. Let me run the program first. Look what happened. The first argument is hello, and within this argv, since it stores the rest of the parameter, so from welcome onwards it will print welcome to Python programming. Next, variable number of keyword arguments. When we are calling the myFUNC function, suppose there are 3 parameters, say Subhash, Chandra and Bose. Shubhas is the first name, this is the middle name, and this is the last name. And if we assign it as F name, then this is middle name, so M name, and this is L name. That's mean the parameter are identified by a name. This is called keyword name. In that case, in the function declaration, I have to give double star, since it's a keyword argument, say keyword, let me write KW for keyword and ARGS for arguments. So I'm writing double star, then a variable name. So this is the technique to be followed when the parameter has some name. Now within the myFUNC function, let me write down like this, since it has a name value pair. So all these arguments contains a name and a value. This is the name, this is the value, this is the last name, and this is the value. So all these parameters have a two attributes, that is the name and the value. For this, within the myFUNC function, I have to write like this: for key comma value in KWARGS dot items. Since parameters are sending as a name value, or you can say key value pair, so you can think that KWARGS will be represented as a dictionary. A dictionary always contain a key value pair. For this one, to extract the key value pair, we have to write the dictionary name and the items. This item returns key value in tuple. So the key will be initialized within key variable and the value will be initialized within value variable. Now in the next line, let me print the corresponding key and let me give me a marker and then the value. Now let me run the program. F name is Subhas, middle name is Chandra, and L name is Bosch. So again I'm repeating, whenever there is a name against each and every value within the parameter listing, and this parameter can be any number of times. So in that case we have to write like this: double star, any variable name. Here I have written KWARGS. So this KWARGS is a dictionary, and we have to extract the key value in the following format: key comma value in KWARGS dot items. So item function of the dictionary return the key value pair in tuple. So we have extracted the key value pair separately within this key value variable. Then we have print this key value in separate lines. Here let me print KWARGS. Let's see what it gives. Look at the output. So this is the dictionary. F name is the key, Shubhash is the value, M name is the key, Chandra is the value, L name is the key, and Bosch is the value. So when there is no concept of key or the keyword, there will be a single star. So when we write a key against all these values, so we have to write like this: double star, then a variable name. Next, this is an important topics under the function of Python, that is the mutable and immutable properties of past data objects. So first of all, let me show you this piece of code. Here a function has been defined, DEF-FUNC, and it has a parameter a, and this function has some lines of code. And from within the main code, here I have called the function FUNC with the parameter n. Now the question is, what is the data type of this function? It may be immutable or mutable. Immutable means integers, string, tuple, etc., and mutable means list, dictionary, etc. So depending upon immutable and mutable data types, the variable behaves differently, and also the function executes accordingly. Now let me show you what happens when we send an immutable type or a mutable type. Let me start with the immutable type. If a variable is referring to an immutable type, then any change in its value will also change the memory address it is referring to. Let me explain it with an diagram. Suppose a is equal to 10. That's mean within memory 10 will be reside in some memory space and a is pointing to that memory space. Now suppose I am writing b equal to a. That's mean b will points to the same memory location. I have already discussed it in the beginning of this video, and we all know that this integer is an immutable type. Immutable means it cannot change in place. That means we cannot change this value within this memory location. So when we are doing b equal to b plus 1, that means b is incremented by 1. The present value of b is 10. That means 10 plus 1 will become 11, and 11 will be stored within b. Since 10 is an integer, it is immutable, so it cannot be changed over here. So another space will be reserved or be allocated for this 11, and then b will now points to that memory location, not in the previous location. So when we print a over here, we will see it is 10. When we print b, we will find that the value is 11. But when we print the id of a and the id of b, we will get two different IDs for a and b after the execution of this line. That's why I have written that if a variable is referring to an immutable type, so let's consider the variable as b. That means if variable v is referring to an immutable type, then any change in its value will also change the memory address. Look, the variable v has been changed its memory location or the memory address, and for that I have written will also change the memory address it is referring to. Next, if a variable is referring to an mutable type, then any change in the value of the mutable type will not change the memory address of the variable. Let me show you an example for that. Suppose I have a list which contains a single element, say 10. Obviously its index is 0. Then let me write down a equal to a. That means a and l are pointing to the same list. Now if I write, say, a0 equal to a0 plus 1. Since a and l pointing to the same list, and this list is a mutable type, that means the value of the mutable object can be changed in place. That means it can be updated. So when I'm writing a0 equal to a0 plus 1, a0 means it represents 10. So 10 plus 1, it will become 11. This 11 will be copied into a0. That means the list is getting updated over here. That means the 0 index of the list will be updated by 11. So in case of mutable object, this operation is not performing in separate memory location. It is changing the value here itself. So when we print the value of L0, we will get 11. So for that I have written, if a variable is referring to a mutable type, then any change in the value of the mutable type will not change the memory address of the variable. So for the immutable type, it is creating a separate memory space for the change, and for the mutable type, the values are getting changed where it is. That means the values are getting updated. No separate memory space has been allocated for this process. Now, by considering this concept, I will show you two examples for the mutable type and for the immutable type. And for each of the cases, I will show how to implement it with the help of a function. In my first example, I will show you how to pass an immutable type to a function. So I'm writing passing an immutable type value to a function. For that, let me define a function, say display. Within this display function, there is one argument, say a. Within this function, let me print inside display the value of a is a. Now let me increment the value of a by 2. Now again, let me print the present value of a. From within the main code, let initialize n with 3. Here let me print before calling display function the value of n equal to, say, n, and then let me call the function display with the parameter n. Let me print the value of n after returning back from the display function. So for that, let me write down after calling display, the value of n is like this. So here the value of n is 3. So before calling display, it will print 3. Now the display function has been called, and the value of n is passed to the display function. So a will receive the value 3 from the variable n. Now inside display function, the value of a will be printed as 3. So look at the example like this. So n is initialized with 3. Now when we are calling the display function, n will be stored within a. That's mean internally it is what happening. A will point to the value 3. So both n and a are pointing to the same value. So when we are printing a over here, so it is printing 3. Now a is incremented by 2. So what is happening? 2 will be added up with 3. Since 3 is an integer, it is an immutable type, so the change will not take in place. So it will create a separate place for 5, and there a will point over there. From here a will be deleted. Now when we print a over here, we will get 5. Now after completing the execution of the function, it will return back to the next line where it has been called. The control will be returned within this line. So in this segment of the code, the value of n is 3. Look, n is still pointing to 3. In other words, we can say that the value of n has been sent to the display function, and whatever the update of a has been done is done within the body of the function only. So the change in the value of a is not reflected back to the main code. Since a is declared within the function, so its scope visibility are within the function only. So whatever the change has been done within the variable a, that will be reflected within the body of the function only. So whenever the controls again return back to the main code, it again regains its previous values, that is 3. The technique of calling this function in this way is called call by value. That's mean we are calling a function by value. In other words, we can say that we are calling a function by sending some value, and if the value is changed within the function, that will not be reflected back into the main code. Let me run the program. Look, so before calling, it will display 3. So in the first print statement within the main code, it will print 3. Then the controller will move to the display function. In the first line of the display function, inside display, the value of a will be 3. Look, inside display a is 3. Now the values of a is updated or incremented by 2. That's why in the next line, present value of a is 5. Look at the output, present value of a is 5. After returning back to the main code, the last line of the main code, after calling display, the value of n is equal to 3. Now in my next example, let me show you what happens when we pass mutable type of value. So let me write like this: passing an mutable type value to a function. For that, let me keep the function name as it is, define display. Let the parameter be a. Inside function, let it be a. Now this time, let me write like this: a0 plus equal to 2. So the present value of a is a. Let it be like this. And within the main code, let me take a mutable type, say a list L, which contains only a single value, and the index of 10 is 0. So before calling display, the value of L is capital L. Now call the function with the parameter L. After returning back from the display function, the value of a will be L. Let me show you the output first. So within the main code, L is initialized with 10. So when you print this list L, it will give me 10 over here. Now the display function has been called with the parameter L. So this L will be copied within A. That's mean L and A both are pointing to the same list, that is 10, and the index of the 10 is 0. Now here, after printing inside display, when we are printing the value of A, so it will print the same list as 10 within third bracket. Now here we are doing a0 plus equal to 2. That's mean we are updating the value of this list. So in the 0th position, 10 is here. So 10 will be added up with 2, and the result will become 12. And this 12 will be stored within this position only. That's mean 10 will be replaced by the value 12. And this is happening in place. So no different memory location is allocated for this operation because it is a mutable type. All mutable types are changed in place. So in the next line, when we print the value of A, it will print 12. After returning back from display function, within the main code, the last line of the main code, the L0 has also been updated because L and A points to the same memory location. L and A are similar. So the L is also become 12 over here also. Here we can say that A is the alias of L, or in other words, A is a reference of L. We can call this procedure as call by reference. Call by reference. That means we are referring L to A. The previous example is the call by value, and this example is call by reference. So when we are passing immutable data types, at that time we will say call by value, and when we are passing mutable data types to a function, we will call it as call by reference. So look at the output. That is why it will be 10, then 10. Within the function, the value of A is 12. And when it's written back to the main code, the L is also become 12. The last property, function overloading. This function overloading is a concept that allows to declare multiple functions with same name having different parameter listing. Let me explain it you by an example. So suppose we have a toDisplay function and both of its name are same. That means we have declared different function with the similar name. But look at the parameters. Here I have written 3 integers and here is 2 integers. The number of parameters are different. From within the main code, when we call the function display with 3 integers, it will call the first display function, and when we pass 2 integers, it will call the second display function. So according to the number of parameters, it is recognizing which display function is going to be executed. Here the parameter listing is very important. Now let me show you another 2 examples. The third declaration is display int comma char, and the fourth, the last one, display is char comma int. Look at the parameters. The order or the sequence of the parameters are different. From within the main code, when we are passing an integer and a character, then the third display function will be called. And if I send character and an integer, then the fourth one will be executed. And for that I have written function overloading is a concept that allows to declare multiple functions with same name having different parameter listing. Look at this example. All these functions have the same name, display, display, display and display, but their parameters are either different in their number or the order or the sequence are different. But like other programming languages do, Python do not support function overloading. Why? Let me show you an example. Look at this Python code. Suppose this Python code contains 2 display functions, def display a comma b, def display x comma y. So when we are calling this display function from within the main code, suppose we are passing the 2 integer values 10 and 20. So it will get confused which function is going to execute, because in Python there is no concept of writing data type at the time of function declaration or in front of this argument. So whenever we are sending 10, 20, it is getting confused which one is going to be executed, the first one or the second one. So that's why I have said that there is no concept of function overloading in Python. But then why I am discussing it over here? Let me show you a Python code. First of all, let me define a function, say product. Let me take 3 parameters a, b and c. Within the function, let me write down p equal to a multiply b multiply c, then print p. Let me declare another function with the same name, say product. And here, suppose I am writing 2 arguments a and b. Here, let me write down a multiply b. Now, from the main code, let me call the function product. Now, during the function call, let me send 2 values, say 5, 6. So during the function call, it encounters 2 integers. That means it will execute this product function, and for that it will return 30. But notice carefully, Python will allow you to write multiple functions with the same name, but it will execute only the latest defined method. It can't access the previous one. You can say that it is a dummy code within the Python program. So if you send 5, 6 and 2, it can't execute. It will give an error type error product takes 2 position, 1 arguments, but 3 were given. So always when you are writing different function with the same name, it will always execute the latest defined method or the function. Latest means the last one, it will execute the last one. It cannot recognize the previous version of this product method or the function. Now if you want to execute the above method, for that what you have to do, you have to move this code under this product function. Now look what will happen. It will execute normally. 5 into 6 into 2, it will give you 60 in the output. Now this time if I delete 2 from here, so it cannot recognize the previous product function, and for that again it will give the error. So by using this function overloading in Python, you can keep this code in your program for the future use. You do not have to delete it, or you need not to comment all these 3 lines. You can keep it as a dummy code. Whenever you want to use this code, just drag it down and make it a latest defined function. So this is all for this video. Still, if you have any problem, write it down in the comment box. I will try to reply you back as soon as possible. Thank you.